Very good morning friends, and in this video again we are continuing from where we left the recording the video that was discussing the trigonometric equations, how to solve different kind of trigonometric equations. And in the previous video you just saw that we were able to solve the equations of the form sine theta is 0, cos theta is 0, tan theta is 0, and then we derived the expressions for the solutions of the kind tan theta equals tan alpha, sin theta equals sin alpha, and the cos theta equals cos alpha. Now we'll be continuing our journey from there, and then we'll be moving to the next step. So first let me put the heading here, that is trigonometric equation. So just a little recap. You just saw that sine theta 0, then theta is n pi and n is integer. Then we had cos theta is 0, then theta is 2n plus 1 pi by 2 and is again integer. It's odd multiple of pi by 2. And for tan theta we had tan theta is 0. We found that theta is n pi, just very much like the sine, because the tan theta is sine theta over cos theta, and then the numerator should be 0, at the same time denominator should be non-zero value. So these three. Then we also saw that sine theta equals sine alpha, then theta was n pi plus minus 1 whole to the power 1 alpha, and cos theta equals cos alpha, then theta is 2n pi plus minus alpha, and then tan theta equals tan alpha, then theta is n pi plus alpha. All this we have done in the previous video. You can watch that video to understand. Otherwise this is I have just put the result. However, the how we have got this result, that was properly derived in the previous video. Now from here I am continuing to the third form of the equation, which says that how will you solve the equation of the form sine square theta is sine square alpha. So if the form is sine square theta is sine square alpha, how will you solve this equation? Then this is what I am trying to derive, the relation. So you know that these two relations can be derived because using the trigonometrical formulas which we have discussed in the other videos also, and same time I am just putting them to try to reconnect. So first I multiply 2 on both sides. 2 sine square theta is 2 sine square alpha. So if this was true, is multiplying 2 on both sides of the equation, the authenticity of the equation will remain so, nothing will change. Now if I just subtract both these terms since they are equals from 1, so 1 minus 2 sine square theta is same as 1 minus 2 sine square alpha, because if these two terms are same, then their subtrahend from the 1 will also remain same. Subtrahend means the remnant after subtracting 2 sine square theta and 2 sine square alpha from 1 will also remain same. So now just look at this relation, then you can find this relation is nothing but the formula for cos 2 theta. So we get cos 2 theta, and that is cos 2 alpha. Now here I return back to this form. So what I see, cos 2 theta is cos 2 alpha, and just you see there is cos theta is cos alpha. It means it is matching the same form. So you can write 2 theta is 2n pi plus minus 2 alpha. Get rid of 2, so theta is n pi plus minus alpha. This is how this equation sine square theta equal sine square alpha can be solved. Now I just want to solve another one for cos square theta equals cos square alpha. This is second form of this kind. Then I'll do the same thing because I have the formula 2 cos square theta minus 1 is cos 2 theta. So I write 2 cos square theta is 2 cos square alpha. Then subtract 1 from both sides. 2 cos square theta minus 1 is 2 cos square alpha minus 1. That is cos 2 theta. This is also cos 2 alpha. Again I reach to the same form. So I'll get 2 theta is 2 n pi plus minus 2 alpha. Then theta is n pi plus minus alpha. And in both these cases n is integer value. This is the equation solutions for cos square theta is cos square alpha. Now I need a little break because I have to clean this. Now we are trying to solve the equation of the form tan square theta is tan square alpha. Now how can we do that? So we will be using the properties of the ratio that first I try to find out, that is called as invertendo. It means if you reciprocal, so you can write tan square theta upon 1 is tan square alpha upon 1. This is the normal, just I put 1 by 1 so that it looks like the form of this. Now I'll use the property of invertendo, is inverting the ratios. So I get 1 upon tan square theta is 1 upon tan square alpha. Now I will use componendo and dividendo, or I can also use dividendo and componendo. That will be more favorable if I use dividendo and componendo. Then I'll get 1 minus tan square theta upon 1 plus tan square theta is 1 minus tan square alpha upon 1 plus tan square alpha. This is called dividendo and componendo. Then I'll do that. This is a formula. This is cos 2 theta is cos 2 alpha. So in all these three forms, sin square theta equals sin square alpha, cos square theta equals cos square alpha, and here tan square theta is tan square alpha, we eventually get to this term, and this term is just in this form. Then we say 2 theta is 2 n pi plus minus 2 alpha, because here theta alpha, here we have 2 theta and 2 alpha. Then 2 is common to each term, so you just get rid of 2. So theta is n pi plus minus alpha. So this is how this equation can be solved. That is of the form tan square theta is tan square alpha. In all these three cases, sin square theta is sin square alpha, cos square theta is cos square alpha, and tan square theta is tan square alpha. The final solutions is coming in this form, same. Theta is n pi plus minus alpha. Now I have just one more form, but for that I need to get rid of this. Okay, so now we have another important form, and that form goes like a cos theta plus b sin theta equals c. B sin theta equals c. How will you solve the equation of this form? So the easier way is that first we need to convert, because we know the formula that cos a plus b, that is cos a cos b and minus sin A sin B for the plus, but here we have plus, so I'll go for cos A minus B is cos A minus cos A cos B plus sin A sin B. So now just one suitable assumption. Suppose if I say that A is R cos alpha and B is R sin alpha, means I am just assuming a right angle triangle of this kind where this angle is alpha and for cos it is A, so this is your adjacent A, hypotenuse is R, so this is B. So using this relationship you just find that you can see that now if you try to just get rid of another way just like square and adding, then also you'll find that R square will be A square plus B square, so R is square root of A square plus B square. And now if you are interested in finding the value of this variable alpha, then just divide second equation by the first equation, then you get tan alpha is B over A. So the alpha is nothing but tan inverse B by A. Why do we need to do this? Because you are given an equation where your variables, you can see that they are A, B, theta and C. Now I assume that A is R cos alpha, means I have changed my variable from A to R in alpha. So I also need to know the relation between the R alpha and AB so that we can later return back to find out those values. So we got the relation R is square root of A square plus B square and alpha is tan inverse B over A. Now, so if you put these values into this equation, what this equation becomes? So this becomes R cos alpha cos theta plus R sin theta sin alpha. Order is not important because A into B is always B into A for the real numbers. So sin theta sin alpha and that is C. So I take R common. Then you see that we are getting cos A cos B plus sin A sin B, this formula. So it becomes cos A minus B, so I write cos theta minus alpha and that is C. So cos theta minus alpha is C upon R. Now assume that C upon R can be represented as some cos B. So the cos beta equals C upon R. Then we have equation cos theta minus alpha is this form, and then here you get the equation cos theta minus alpha is cos beta, that is theta minus alpha is 2n pi plus minus beta. So this goes like this, and then later you can write theta is 2n pi plus minus beta plus alpha. So these two are same thing, but since they are interested in finding out the theta, that's why this equation where the theta is the subject appears to be the more suitable and appropriate. So this is all for the trigonometric equations. Now after cleaning this, I would like to show you how to solve this equation using the formulas, because these are derivations and now I'll solve some real. Now we have an equation to solve, that is 2 sin theta plus 1 is 0. Then you have to solve this equation and check what kind of values you are going to get. So what I do, that I write 2 sin theta, that is minus 1, sin theta equals minus 1 upon 2. Now if you use the values, then you know that this one sin theta equals minus sin 30 degrees is 1 by 2, and the 30 in the radian can be written as pi over 6. So this is sin 30 and this is minus half. Now this minus is not required here. So how to get rid of this one? Now what will be the value for the negative? So we know that cos, if you see this term as TC, so the cos can be negative in either third quadrant or in the fourth quadrant. Third quadrant means 180 plus theta, and the formula goes like this: cos pi plus theta is Sine pi plus theta is minus sine theta. So here this equation will become sine pi plus theta, that is pi over 6, and this is theta. So this sine theta is sine 7 pi over 6, and then we have the relation that is n pi plus minus 1 whole to the power 1 7 pi by 6. Now since n is the integer value, so I just put n as 0. Suppose if I put n is 0, then this is 0, this is gone, so the first value I'm getting is 7 pi by 6. If I put n is 1, then this is n pi, that is pi. This becomes minus 1 to the power 1, that is 1, minus 7 pi by 6. Then you get 6 minus 7, that is minus pi by 6. This is second value. If you took n equal to 2, then this is 2 pi plus 7 pi by 6. 6 to 12 is 7, 19 pi by 6. This is third value. If you take n equal to minus 1, then you get your answer as minus pi. Minus 1 to the power minus 1 is how much? That is 1 over, first 1 over minus 1 to the power 1, that is 1 over minus 1, and this is minus 1. So this is minus and then minus 7 pi by 6, and you get minus 13 pi by 6. So all these are solutions, and since it's a periodic function, you will get infinite solutions. But if in the question sometimes they ask, they restrict the questions like theta belonging to the closed interval minus pi to pi, so you have to select only those values of theta which are lying between minus pi to pi radians, or you also say that they are lying between minus 180 degrees to 180 degrees. So this is how these equations can be solved. Now let me clear the mess, and then I solve another equation just to elaborate you. Now I have another equation which is 7 cos square theta plus 3 sine square theta equal to 4. Now we have to solve this equation. So this is cos square theta, and you know that the relation between sine square theta and cos square theta goes like that. Cos square theta plus sine square theta is always 1. So this 7, at the place of cos square theta I can write 1 minus sine square theta plus 3 sine square theta is 4, that is 7 minus 7 sine square theta plus 3 sine square theta is 4, that is minus 4 sine square theta is minus 3. So sine theta is plus minus under root 3 by 4. So sine theta equals plus minus under root 3 by 4. So here we have the form, sorry, this is 3 by 2 because square root of 4. So I go first by positive, you can take any one of them to repeat. So it is root 3 by 2, and then sine theta is sine pi by, this is 60, sine 60 is root 3 by 2, that is pi by 3. Then theta is n pi plus minus 1 whole to the power n pi by 3. If you take n equal to 0, then theta is pi by 3. If you take n equal to minus 1, then this is minus pi by 3, that is minus 4 pi by 3. If you take n equals 1, then this is pi minus pi by 3, that is 2 pi by 3. Same way, you keep on putting the different integer values for the n, and you keep on getting the different values of the theta. These are your solution. If there is any restrictions for the angle, then you can figure out to which domain you want your t ratios to be. So this is how this equation can be solved. Now I solve one more equation, and then our elaborations will be complete. Now we have another equation, that is root 3 cos theta plus sine theta is root 2. Yes, this root 2. how to solve this equation. This equation goes in the form of the previous equation which I just discussed, that was a cos theta plus b sin theta equals c. So first I have to say that let root 3 equals r cos alpha, and then here I have the 1 hidden, therefore 1 is r sin alpha square, and add, so we get 3 plus 1 is r square, therefore r equal to 2 if you ignore the sign, and if you just divide this by this you get tan alpha. Tan alpha is 1 over root 3, therefore alpha is tan inverse 1 by root 3, and that is alpha is 30 degrees or pi by 6. So we have got our values r and this equation will become r cos theta minus alpha is this one, root 2, and what is r? R is 2 cos theta minus pi by 6 is root 2. So cos theta minus pi by 6, root 2 over 2 will be 1 by root 2, and this 1 by root 2 is pi by 4 cos. So the cos theta minus pi over 6 is cos pi over 4. So it is again in the form of cos theta is cos alpha, therefore theta minus pi by 6 is 2n pi plus minus pi by 4. Theta is 2n pi plus minus pi by 4 plus pi by 6. And then you can keep on putting the values of n, different integer values for n, and then you can get the values. Like suppose if I put n as 0, so if n is 0, then I get two values, plus minus pi by this, I get pi by 4 plus pi by 6 or minus pi by 4 plus pi by 6. So this is 3 over 3 multiplied up and down, 312, and the 212, that is 5 pi by 12. This is 312, and then the 212 is minus pi by 12. So if you take n equals 1, then here become the 2 pi plus minus pi by 4 plus pi by 6. So you have to solve this also. Again you get the two such values, one for positive, one for negative, and that will give you a set of the values of theta for this appropriate equation. So this is all for now in this video. In the next video we'll discuss about the inverse trigonometric functions. So get ready for that.